Hello innovators, welcome back to the Robot series, where we learn, earn, build, and innovate using technology and creativity. In today's episode, we are going to explore one of the most essential topics in electronics, power systems. Every circuit, device, and robot needs power to function. And understanding how power flows through your system is key to building efficient, safe, and long-lasting electronic projects. When we talk about power systems in electronics, we are referring to all the components and methods used to supply, regulate, and store electrical energy. Power is like the blood of your project. It gives life to sensors, microcontrollers, motors, and displays. Without a proper power source, even the most well-designed circuit won't operate correctly. In this episode, we'll explore batteries, voltage regulators, power adapters, and solar systems, understanding how each works and how to use them safely and effectively. Let's begin with batteries, the most common source of portable power. A battery converts chemical energy into electrical energy through electrochemical reactions between its terminals. It has a positive terminal called the anode and a negative terminal called the cathode. The potential difference between these terminals is the battery's voltage. For example, a single AA battery provides 1.5 volts, while a typical 9-volt battery can power simple circuits. In electronics and robotics, we often use rechargeable batteries such as lithium-ion or lithium polymer, LiPo, batteries because they provide stable voltage and can be recharged hundreds of times. A common Li-ion battery provides 3.7 volts, and when connected in series, they can supply higher voltages such as 7.4 V or 11.1 V. These batteries are lightweight and ideal for powering Arduinos, sensors, and small motors. However, they must be handled carefully since overcharging or deep discharging can damage the cells or even cause safety issues. That's why we use a battery management system, BMS, to regulate charging and discharging safely. Next, we have voltage regulators, the heart of every stable circuit. A voltage regulator ensures that your components receive a constant voltage, even when the input power fluctuates. There are two main types, linear regulators and switching regulators. The 7805 is a classic example of a linear voltage regulator that outputs a steady 5 volts, making it ideal for powering logic circuits or microcontrollers like the Arduino Uno. It requires a minimum input voltage of around 7 V and can handle small variations in input. On the other hand, switching regulators or buck converters are more efficient because they use transistors and inductors to step down voltage with minimal energy loss. For instance, the LM2596 module is a popular DC to DC converter that can take an input voltage up to 40 V and output a user-adjustable voltage, making it ideal for robotics and IoT applications. Another essential source of power is power adapters. These are external devices that convert AC voltage from the wall outlet into DC voltage, suitable for electronic circuits. A typical 12 V DC adapter can power Arduino projects, LED strips, and small motors. Most adapters provide a specific current rating, for example, 12 V2A, which means it can deliver a maximum of 2 amps of current at 12 volts. When choosing an adapter, always ensure that the voltage matches your circuit's requirement and that the current rating is equal to or greater than what your project needs. Using an adapter with lower current output can cause overheating, poor performance, or component damage. Now let's talk about solar power systems, the clean and renewable source of energy that's becoming more popular in modern electronics and STEM projects. A solar panel converts sunlight into electrical energy through the photovoltaic effect, using semiconductor materials like silicon. The power output depends on the panel size and the intensity of sunlight. A typical small panel used in robotics provides between 5 V to 12 V, with a current range from 100 mA to 1A. To store solar energy, we use rechargeable batteries connected through a solar charge controller. The charge controller regulates the voltage and current coming from a solar panel, preventing overcharging and ensuring the battery safety. Solar systems are excellent for outdoor IoT devices, environmental sensors, and sustainable robotics projects. To integrate these power sources efficiently, it's important to understand voltage and current ratings of your components. For example, most Arduino boards such as the Uno, Nano, and Mega operate on 5V logic, while others like the ESP32 or Node MCU operate on 3.3V logic. Supplying more voltage than required can permanently damage microcontrollers or sensors. Therefore, power regulation is not optional, it's a necessity. Similarly, when connecting motors or actuators, always ensure that your power supply can handle the required current. For example, a small DC motor may draw around 300 milliamperes, but a servo motor could draw up to 1A or more during movement. Grounding and polarity are also key elements in power systems. The negative terminal of the power source is usually connected to ground, GND, in the circuit, which serves as a common reference point for voltage measurements. Reversing polarity, connecting positive to ground or negative to VCC, can destroy components instantly, so double-check your connections before powering your project. Let's not forget about power distribution. When your project grows, it might include multiple modules requiring different voltages. In such cases, you can use power distribution boards or buck converters to provide separate voltage rails such as 12V, 5V, and 3.3V from a single battery. This ensures each component receives the correct voltage without overloading any single line. In advanced robotics, we also use power monitoring modules such as the INA219 sensor to measure voltage, current, and power consumption in real time. This helps detect faults, estimate battery life, and improve system efficiency. In summary, a good power system is the backbone of every successful electronic project. Whether you're using a simple battery, a regulated adapter, or a solar setup, always consider safety, voltage compatibility, and efficiency. By mastering how power flows and is controlled, you'll build more reliable, efficient, and eco-friendly systems that can power up your creativity in the world of electronics and robotics. And that wraps up today's episode on power systems in electronics. In the next episode, we'll explore communication modules, how our robots and systems talk to each other using Bluetooth, Wi-Fi, GSM, and more. Don't forget to like, subscribe, and share the Robot series, where we learn, build, and innovate together.